Okay guys, take a look at this picture on the screen. You have a bowl of fruit on the left hand side and you have a bowl of fruit which is of a different design on the right hand side. What's going on? What do you notice? What do you think might be happening here? Pause the video and have a little think about what is going on. Okay, on the bowl on the left hand side you have bananas mixed with all sorts of different fruit. On the right hand side you have some bananas hanging in a special fruit basket away from the rest of the fruit. The reason for this, and you might have noticed this, is that bananas give off a gas. Bananas give off a gas called ethene. Not ethane, but ethene. And ethene ripens other fruit. So the fruit basket with the hook on the right hand side where you can hang your bananas is a very, very clever design because it stops the ethene building up in the bowl over ripening the other fruit. The ethene is able to blow away effectively and won't fall onto the fruit below. Ethene is an alkene compared to ethane, which is an alkane. Ethane contains single carbon-to-carbon bonds, whereas ethene contains a double carbon-to-carbon bond. So how many carbon atoms are there in each molecule? I want you to remember the key fact that we went through which is that carbon always forms 4 bonds. I'd like you to think about how many hydrogen atoms will be in each molecule and therefore write down the molecular formula for ethane and ethene. It may help you to first draw out the displayed formula for each molecule, remembering that carbon always forms 4 bonds. I'll give you a few minutes to give that a go, maybe 5 at the most. So please pause the video and then we'll run through the answer shortly. Doesn't matter if you don't get it right. All I'm bothered about is that you give it a go. Well done for giving that a go because I know it's quite difficult. Ether 2 carbon atoms, as will ethene, both contain 2 carbon atoms. Remember our nice little mnemonic, monkeys eat peeled bananas. Ethane though, with carbon forming 4 bonds in each case, ethane will contain 6 hydrogen atoms because each carbon forms 4 bonds. Each carbon has a single bond to the other carbon, so that leaves 3 bonds remaining. It is saturated. There's no more space for any hydrogens. In the case of ethene, ethene will have a double bond within it. It's an alkene. So as a result, it will have 4 hydrogens within it. Because carbon can only form 4 bonds, and if it's already used 2 bonding to another carbon, then it will only have space for 2 more bonds. Hence, ethene will have a formula of C2H4. If you haven't gotten this down into your books, I'd like you to write it out. I'd like you to recognise that what is on the left-hand side is an alkane, which contains single bonds, and what is on the right-hand side is an alkene, which contains double bonds. Right, next thing then. Remember that alkanes contain single bonds and alkenes contain double bonds. I'd like you to take a look at the images on the screen and tell me which is an alkane and which is an alkene. I'll give you a few moments to do that, a couple of minutes, so the cover teacher can pause the video lesson and I will go through the answers once the video is resumed. Okay, I'm going to go round the screen here. So CH4, a little pen here. So this guy here is an alkane. It has single bonds here, single bonds. propene, given that there's an E here, will contain double bonds. It is an alkene. There's a big clue in this guy here because propane, it says on the cylinder propane, so that will be an alkane. Saturated molecules mean that they have no more room for any more hydrogen. They are essentially full up. That means they contain only single bonds. So as a result of only containing single bonds, they are saturated with hydrogen. Single bonds means saturated with hydrogen. That means an alkane. Right? I'll just put an arrow up here to the fact that this is an alkane. As before, ethene will be a alkene. This guy down here is propane, so that is an alkane. Methane will be an alkane. Ethane will be an alkane. The fact that this molecule here, we've just written this down, is ethene. That means that it is an alkene. This guy here, propene, has a double bond. Therefore, butene, there are 4 carbon atoms here. So that will be a alkene. Unsaturated, well, if saturated molecules contain single bonds, unsaturated molecules will contain double bonds, which means that unsaturated molecules are alkenes. Butane, therefore, will be an alkane because of the A there. This guy is ethane, which is an alkane. Propane is an alkane. Butene is an alkene. This guy up here is propene because it has a double bond here and 3 carbon atoms. Therefore, it is an alkene. Well done, guys. In your books then, I'd like you to draw propane out, very much like how we drew ethane out at the start of the lesson. And then I'd like you to draw propene. Hopefully you'll be able to tell me, if we've been paying attention carefully, which is saturated, which is unsaturated, and why. Perhaps you can go one further and tell me the general formula for n number of carbon atoms. How many hydrogens will you have for each type of molecule? It's a challenge. I'm going to give you about 4 minutes to do this. The cover teacher can pause and then we'll go through the answers. Here are the answers then, guys. Propane is on the left hand side. It has 3 carbon atoms because monkeys eat peeled bananas. Meth, eth, prop. So prop means 3 carbon atoms. So both propane and propene contain 3 carbon atoms. Propane has only single bonds in it. It's therefore saturated. And as we learned last lesson when we went through this, it has the general formula of CnH2n plus 2, which means it will have a formula of C3H6 would be 3 times by 2 plus 2 makes 8. So this has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens in the molecule, so it will be C3H8. Propene is unsaturated because it has a double bond. Right, here's our double bond here. Remember that carbon can only form 4 bonds. And it will have the general formula CnH2n. It has here 1, 2, 3 plus 3 makes 6 hydrogens. There are 3 carbons. 3 times by 2 makes 6. So it means that the general formula here, CnH2n, is the general formula for an alkene. Make sure, guys, that we've got that written down, that these general formula down here we need to know, and we need to know the fact that alkanes are saturated and alkenes are unsaturated. Alkanes saturated, single bonds. Alkenes unsaturated, double bonds. We've done a great deal of setup here. in terms of what we're really learning about today. And it is getting jolly close to Christmas, so I haven't just purely placed a cracker on the screen, but I've placed a cracker on the screen because we're thinking about cracking hydrocarbons. So here's a Christmas cracker. The cracker, when it's together before it's been cracked, if you like, represents a long chain hydrocarbon, an alkane. But it can be broken down into smaller substances by a means called cracking. You always end up with an alkane and a shorter alkene. Let's make some brief notes on this before we watch a little video about alkanes and alkenes and cracking more generally. So what is cracking? Cracking is the process of taking long hydrocarbons and breaking them into shorter, more useful ones. So think about this situation here, your alkane here. All right, here's a long alkane. You're cracking it and you're forming a shorter alkane and a short alkene. That in an essence is cracking as a process. So can you just pause the video, guys, write down these two key bullet points just here. That cracking is the process of taking long hydrocarbons and breaking them down into shorter, more useful ones. You take a long alkane, you crack it into a shorter alkane and a really short alkene, just like a Christmas cracker. Okay, we're going to watch a short video now. You don't need to make any notes during the video. All you need to do is to pay attention carefully. It's important that you do because what we're going to do next very much relies on you having paid attention to the video. Right, having watched that video, guys, I'd like you to draw out a molecule of decane. Decane is a molecule that contains 10 carbon atoms, as shown on the screen. Remember that each carbon forms 4 bonds. I'd like you to crack the decane into octane. Octane would contain 8 carbon atoms, and ethene, which is an alkene, which will contain 2 carbon atoms. But remember, in ethene there is a double bond. So octane is a resulting alkane, ethene is a resulting alkene. And I'd like to draw it out in a similar style to the diagram above. Please pause the video to do that now, and I will then go through the answers shortly. In terms of the answers then, guys, here's decane. It was on the previous slide. It has the molecular formula C10H22. After all, it is a alkane, and it has the general formula CnH2n plus 2. 10 times by 2 is 20, plus 2 makes the age-old 22. Octane is formed as a result when you crack decane. One of the possible products is octane, which has the molecular formula of C8H18, because 8 times by 2 is 16 plus 2 is 18. It has single bonds, it is therefore saturated. This is your shorter alkane. You also form ethene, which is an alkene. It has a double bond here, which has the molecular formula C2H4. It is an alkene. As such, it has the general formula CnH2n. Well done if you got that right. I'll give you a bit of time now just to pause the video to write this down and amend your answer as necessary. Okay, let's move on to a little graph here. What do you notice about this graph? This is supply and demand for crude oil products. Supply is in this sort of lilac colour and demand is in this sort of burgundy colour. How do we meet demand for petrol given that there is a much greater demand for petrol than we have supply for? Have a stop and have a think. Pause the video, have a chat for a minute or two, and then we'll go through the answers. Okay, the astute amongst you might notice that fuel oil and bitumen, which are longer hydrocarbon chains, for the situation for petrol is that the demand far exceeds the supply. But for fuel oil and for bitumen, the supply far exceeds the demand. So maybe we could crack fuel oil and bitumen, being longer chain hydrocarbons, and produce shorter fractions like these ones down here. So how do we do it? We crack a heavy fraction such as bitumen or fuel oil that has a low demand but a high supply. We pass that fraction over a hot catalyst which is at between 450 and 550 degrees C. Those large molecules break down, they decompose into smaller ones to produce a product that contains alkenes and alkanes. The alkanes are used for fuels and the alkenes are used to make plastics, to make all sorts of other products, and they're very, very reactive species. Final thing to look at here today then, guys, as a plenary is to link the words. I'd like you to draw on some links between any of the words here that you think are applicable, having seen everything that we've seen, watched all the videos and so on. I'll give you, about 5 minutes to do that before we go through the answer. Please pause the video to do so. Okay, on this slide, this shows the links that I would draw, although you may have more. Alkenes and alkanes are both hydrocarbons. Alkenes contain double bonds, whereas alkanes contain single bonds. Alkenes and alkanes, you can react them with bromine water, although alkanes being saturated are unreactive, so the bromine water stays orange. In the case of the alkenes though, the bromine water, because an alkene is unsaturated and the alkene is therefore reactive, the bromine water goes from being orange to being colourless, demonstrating that the reaction has gone through to completion. Thanks ever so much for your attention, guys. If you have finished all of this and gotten through this video lesson without any issues, can I advise you to look back over your notes and to write down 3 key things that you have learned today. Maybe you could even write some questions for the person next to you. Thank you for your attention. I'll see you next time.